everybody. Welcome to the Embracing Ceph panel discussion at Cephlicon. My name is Laura Flores. I am a Rados engineer and the chair of the User Dev Monthly Meeting.
And I'm Dan, a member of the Ceph Executive Council.
Hello, I'm Vasyl. Okay.
Yeah, with this discussion, we're hoping to hear directly from our community about what factors went into their decision to use Ceph. We've invited these 5 panelists, each bringing a unique and important point of view to the discussion. This panel will start with some prepared questions from your hosts, Dan and I, and hopefully we'll have time for a few questions at the end. So think about any kind of questions you'd like to ask the panelists.
So to the panelists, we have around 5 or 6 questions prepared. We asked to get everyone time. We each spend about a minute on your answers. But to get started, could each of you just maybe briefly introduce yourself?
Yeah, I'm Vasyl, working in Workday, senior software engineer in storage team. And Workday is a cloud platform for HR applications.
I'm Andras. I'm a senior data scientist. I work for Flatiron Institute, which is a research arm of the Simons Foundation. And we are a computational science nonprofit research institute doing research in various disciplines from neuroscience to computational biology, astrophysics, quantum systems, and mathematics, computational math. And we have a fairly good HPC cluster and a quite sizable Ceph set up to do the large data, to deal with the large data.
I'm Luca. I'm an infrastructure architect at the Pawsey Supercomputing Center in Western Australia. And we are a supercomputing center that supports all the universities in Australia. And also, we will be, in the future, the main base of operation for the data ingest for the SKA telescope. And we have most of our infrastructure is HPC, plus Ceph for data ingest, and Luster for HPC, for the HPC center.
Cool. I'm Leonard. I'm from Bloomberg Engineering. I'm the head of storage engineering there. So our area is responsible for providing all of the storage assets to the engineering organization above us. So that's 7,000 engineers worldwide. We're responsible for file, block, object, data protection, and a bunch of other interesting things. We leverage Ceph for block and file, mainly to power kind of like our next generation cloud, moving towards virtualization and S3.
Yeah, I'm Frank Yang. I'm the CTO of Platina Systems. So we're a small startup compared to everybody else here on the panel. And so we provide private cloud solutions and software to our customers. And also that solution, at least the storage part of it, is all built on top of Ceph.
Thanks so much. We'll get started on the questions now, and we'll try to keep it to 1 minute per panelist, to the best of our ability. All right, so for our first question, could you share what were the key deciding factors that led your organization to use Ceph?
So for us, the journey started when we were trying to move Kubernetes solution from AWS into the data center, and we needed both block and object storage available, and having that from a single system is obviously a good reason. Apart from that, Workday is a huge customer of OpenStack. So whenever you're talking about OpenStack and storage for it, you would always go for Ceph in most cases. So Ceph was obvious choice for us. And apart from that, as bonus points, we had that you can actually configure a system as flexible as you can for cost effectiveness. You can have small clusters, but very speedy, or huge ones for archive queues and so on.
So we started with Ceph when Ceph was still somewhat experimental, at least the file system was. And we started small. And our initial small Ceph setup really worked well and worked better than the previous solutions what we were using. So we grew and grew bigger and bigger and bigger in Ceph. And I guess what we like, what are the driving points is, one is that it's an open source community. We are a research institute. We deal with open source software. Most of the stuff that our scientists work on ends up open source, so that was very attractive. The reliability first design, I would say that that's a key point, that the number one goal is not to lose data, and then we'll try to do the best performance on top of that, versus the other way, that we start with performance. Lots of HPC file systems, we start with performance, and then, well, hopefully it's reliable. And the flexibility of it, that you don't just have can't do a file system, but you can tweak things. You have other APIs like Block, and which we use. S3, we not so much today. And the vibrant community, that generally when we had problems, we can get someone to help us or someone to have insights on them fairly quickly.
For us, is the combination of you two. We started with an OpenStack cluster in 2016 and just using Block. We were very happy with that. And we chose Ceph for the next cloud iteration, so we were able to migrate all our Block storage, the virtual machines, without any downtime. And this was actually the driving factor that brought us to adopt Ceph even further. We are planning to host the SKA data on part of the SKA data in our data center, and we are talking about 300 petabytes per year from 2025-26. So we've seen many solutions. We did many requests for quotations and idea of how we could have supported that. And Ceph, we were used to Ceph. We liked already the way they operate, the community, and the support that the community gave us. And Ceph was essentially the number one solution for achieving this, mostly because it's reliable, but also because it is possible to scale the solution you currently have without any downtime and keeping the researchers happy, in our case.
I would say that we didn't choose the Ceph life, it chose us. Bloomberg's been playing in this space for a long time. We were early adopters to the Open Infra and OpenStack projects. Ceph was kind of like the default back then, and then it just kind of took off and grew from there. Then we added the object side. So that's how it came to us. The reason that we still continue to use it and why we kind of believe in it is some of the things that the other panelists have said. So I won't kind of repeat that, but if any of you saw our talk earlier today, the biggest thing is the community and the open source, the ability to kind of choose and control your own destiny, right? If there is a feature or a bug or an issue that's impacting Bloomberg's ability to get done what it needs to get done, we can roll up our sleeves, we can jump into the code base, we can, work with the rest of the community to identify the issue, solve the issue, fix it, and not just fix it for ourselves, but fix it for everybody. So that's kind of like the big thing for us right now.
Yeah, for us, it started when one of our first and largest customer, it's a major sports league in the United States. So they have a requirement where they're needing to archive tens and then growing to hundreds of petabytes. So scalability was important for us, and this is using S3, so we're using the Rados gateway. So that was one of the main driver. The TCO requires us to basically do it with open source. There's all the open source out there that supports this kind of scalability, mature enough, reliable enough, has large enough community to support it. I mean, it was an obvious choice. And then over time, the fact that it can do the block and the file system even for private cloud, that just add a bonus to using Ceph.
That's great. So I hear like three themes. Like, it was the obvious choice when you started with OpenStack. It was the obvious choice when you were starting with a reliability first HPC. An obvious choice when you're starting recently with object. Okay, that's good to know. Second question, how has Ceph's open source nature brought value to your organization?
So we value security a lot, and we actually had a few features missing from Ceph, and it was very comforting that we actually could, instead of waiting for some vendor to go and implement that for us and just have that time without you knowing that will it work for you or not, you actually can do that yourself, prove that it works, then contribute upstream, and so on. We do have support from Red Hat for our solution for corporate support, which helps a lot to speed up the open source contributions process. But most of the changes that we actually need, we do ourselves. So we did contribute to Ceph CSI driver for Kubernetes to add encryption keys there and so on. And we also contributed to S3 to have Vault as KMS for it, because that's decided solution for our company for security management.
I think for our case, a lot of our people are fairly technical, so we like the idea that we can roll up our sleeves and look at things. So if something is slow, we can pull up a debugger and see exactly which function is doing what, and look at the source code and see what happens. And that's kind of comforting that if something really bad happens, perhaps we have at least a chance of doing something instead of being at the mercy of a vendor. We don't have a vendor lock-in, so we're not tied to one specific vendor's patches or releases, etc. So, it's also easy to try things. So if we wanted to see, well, how often does such and such a condition happen? We've changed the code to see, well, let's count this and see, does this ever happen in our case or not, etc. So you can do experiments or try patches that people have developed very, very, very easily. So it's more agile framework, which is kind of in line with research, that's in line with our mission.
For us, it's the combination of the two panelists already said. We already had problems, and we had to patch the system in some ways prior to the release. We also work with very large HPC systems and HPC vendors. And yeah, with closed source, you still have the problem that when things don't work, you can't have a look. You have to ask for the vendor to check what the problem is. Then the communication with the vendor takes time. Often it's not very easy to explain what the problem is, or it presents only a scale. So it's even more complicated. And for us, we found out that the open source is the way.
Yeah, kind of similar. So Ceph can sometimes be difficult to understand or operate, and having the ability to reach out to everyone that's used it or contributed to it and having that kind of knowledge base is really helpful. It's like a nice safety net to know that if you do run into some sort of issue or some sort of weird corner case, you can reach out to the members, the developers, the community, and say, hey, this weird thing has happened. Has anyone seen this before? Has anyone recovered this? And like most of you are all probably on the mailing list, just even seeing the community, like, somebody throws out the bat signal, like, oh my God, my cluster's down, what do I do? This is what I get. You just start to see the responses coming in. Have you tried this? Have you seen this? Have you looked at that to help recover? So that part of being part of that kind of open source community, and a community that cares about the technology and cares about each other is a really nice kind of feeling, and that's kind of what we like about the open source.
Yeah, from the support side, definitely echo all the other panelists. There's the community to tap into. There is a plethora of documentations out there. I mean, maybe too much, but if you search hard enough and have enough patience, you usually can find what you need, and if not, you can always ask the folks. And for us, we're all software developers within Platina, so when needing to get to the source of truth, we can always go to the source code, and so you know exactly what you're getting or what you're not getting. But the other part of on our side that's different is we have our customers, right? So using an open source, give them the sense of security that if Platina were to go away, that this is a open source community-backed project. So even if they had to, for whatever reason, take it over and manage it themselves, that they can. So that was important.
That's great. So I'm kind of hearing a common theme of, or whether you want to, your expertise level is that you want to dive into the code, or that you would rather talk to an expert and get answers that way, or from just the community itself, there are ways that you all have been drawn into that, whatever your expertise or interest level is. So that's really great to hear. So our next question is, what challenges or surprises did you experience when integrating Ceph with your organization or infrastructure?
Yeah, so slightly diving to the previous question. With open source Ceph solutions, there is a lot of automation already there. All the monitoring dashboards, Ceph dashboard, all the tooling that you can use, Ansible playbooks if you want, and so on. But even with that, there was still quite a bit of a challenge to integrate that all built up knowledge and automation into our own infrastructure. We're still running Ceph Ansible for that, and we did have issues because Workday was not using Ansible previously. Luckily, there was another project that was actually starting to use it. Apart from that, as I mentioned, we had some security concerns to make sure that you're not using a single encryption key or something across the board, so to enhance security. And as for challenges, unfortunately, we hit a couple of them. One of them was pretty bad, a bug in the kernel, which was causing our MySQL clients to actually reboot, which was causing downtime for Workday customers. So that's, but we found with help of community and Red Hat, we managed to overcome that. And another one was with S3 policies. Again, there was a bug in Ceph, which was not obvious until you hit it. And being able to actually see the code and find that, okay, this is a piece that changed and this is causing your issue, and figure out how you can fix it and contribute so that other people who are using it elsewhere will not hit the same issue again.
Okay, I want to touch on maybe a couple of points. The first one comes up on mailing list a lot, is hardware. That most often if you buy a solution from a vendor for, let's say, a file system, then they'll ship you some machines. It runs their proprietary software, and that's what you use. With Ceph, you get the software, but you are in control of choosing your hardware. And then, of course, Ceph says, well, it runs on community hardware. You don't need commodity hardware. You don't need specialized hardware to run Ceph. But that doesn't necessarily mean it runs on everything well. So I guess what we had to learn over time is what are the things that are good ideas in hardware and what are not so good ideas. And this keeps coming up on the mailing list. Commodity SSDs versus enterprise, how powerful machines to get, how big are the various, WAL and DBs and this and that. So lots of decisions that you build up knowledge over time. And that the hardware choice is an important one, and even to this day, when we change the hardware, we always go through a rigorous testing procedure of it's not enough even to look on paper what the vendor says that this hardware can do. You have to actually test it out. That's one. And the other is that most of the challenges that we run into nowadays relate to scale, that we run probably one of the larger CephFS installations, and we typically run, the issues we run into have to do with the scale, the number of clients and the number of parallel transactions that happen, the number of files created per second, the number of files in the system, and metadata and that sort of stuff. Now, that's the major challenge for us nowadays.
For us is a similar experience for the hardware, and also when you go to mailing list, there are a lot of people that say things that most of the time are the same, sometimes are completely different, because people have experience with different hardware, because they have experience with different deployment sizes. So sometimes what's your configuration can't really apply to something else that someone else has, or a different size or a different release. And but most of the time the community is very active, and your original testing infrastructure is always got us to the point we want it to be. And in terms of the positive is that we, prior to Ceph, now we just use Ceph and Rados Gateway and S3 for storing the data for the old center. Before we were only using file systems, and through the migration from GPFS and CXFS, we always relied on Ceph as dump things there. It's always going to work, and you're never going to have problems. And this was the case all the time. We just free up all our 7 petabyte GPFS cluster, just dumping it to Ceph. We have no issues, and we did the same for CXFS. and we discontinue all of them, and now we just run Ceph and Luster because we have to for the HPC system, and we don't have any issues.
I would say if we look at it, I can see some challenges in our infrastructure. One is upward looking to the applications and the internal clients that use it, and one looking kind of downwards to our own stack and kind of even into the community. That one's like a little bit easier to talk about. We love bare metal. Pry it from our cold dead hands. It seems the community is starting to move away a little bit from ease of deployment onto bare metal. It's moving more towards containerization. So I foresee that being an interesting challenge that Bloomberg's going to have to understand going forward. But this is like the power or a success story of Ceph. It does S3, it does block, it does all sorts of cool things. And when it does cool things, people get expectations that it will work, and it will work consistently. It will stay kind of relevant with what's going on in the world. So we run an internal private cloud. It's over 100, if not hundreds of petabytes of block and object, and S3 is really large in the tech space these days, and it's an ever-evolving protocol, and it does interesting things, and it can push interesting challenges into us as the administrators of storage based on what applications are doing, right? So machine learning, AI, like Hadoop, Spark, Iceberg, these platforms, when they interact with S3, it causes all sorts of interesting challenges kind of downstream in our world. And I would say that given that that's the level, you know, if I install Spark, it comes with an S3 plugin, S3 should just do what it does. That expectation floats down to us, and then we have to kind of work within the bounds of Ceph and the community to make sure that that works. And that puts a lot of infrastructural challenges on us, because that space is evolving so rapidly that we have to keep evolving so rapidly to keep up with it. Otherwise, you know, we're going to get left behind.
Yeah, for us, it's the many knobs within Ceph that can be tuned. Like we started off in the way beginning when we were just starting, you know, with a lot of the defaults and kind of learn our way through, especially in these larger clusters, you know, how to tune them, fine tune them. Our customers bring in their own hardware, so we have to deal with different kinds of hardware. And again, depending on your environment, your applications, your hardware, your scale, the knobs are tuned differently. And we're doing all this via software, right? So we have to understand ahead of time and then write the software that kind of automates some of these, remediate. And it does feel like a lot of time, you know, just lots of time spent on experimenting before we can roll something out into production. And so, you know, that continues to be a challenge, right? And it gets better, and we're learning from the community. But it does seem like every day there's something new popping up, and you know, we have to deal with.
Okay, so cool. I'm hearing like, missing hardware recommendations. Maybe this is a common theme coming up often today in other discussions also. Maybe the flexibility, the workloads. Like, this is something else that's coming up as well. Maybe we shoot ourselves in the foot by being too flexible sometimes. Okay, next question. From your experience, what does Ceph need most to attract new organizations to our community?
Yeah, for this, probably Ceph needs a bit more maturity in the basic features. So for example, there is RBD devices for block storage, but not for all platforms. It is supported to replicate to another system or something. There are different ways to replicate, but when you have a live system that is already using it, it's already becoming problematic. And apart from that, there are some features that are missing comparing to some vendor utilities. For example, it's, as was mentioned, it's really hard to find the hardware that suits you, especially when you have new use cases. In general, you don't have specific requirements, what it needs to meet. So you're trying to match some hardware to cost, and you don't have some utility for capacity planning or how much like to simulate the workload that you're planning to run there, and until you actually try it yourself. And as for us specifically, if you're running many clusters, at the moment most community and everything is focused on having a single cluster that is large or small and being able to manage it manually. But when you have many clusters in many different data centers and so on, it slowly becomes a burden that you need to make sure that every single cluster is at the same level. They all are performing as they should, and just to keep up with the upgrades and with everything.
I was going to say that a lot of people I talk to who are not Ceph users, their challenge is documentation, how to get started with Ceph. So Ceph has a lot of documentation, and a lot of it is very kind of reference-like, encyclopedic reference-like. So all the 1,000 or so whatever configuration options are all documented. But from a beginner's point of view, just get started. Well, which ones do I change out of those? Where do I start in this C? So earlier there was a talk. Earlier in the discussion, it was mentioned that there are some efforts to write like a beginner's guide to Ceph and kind of how you get going at the beginning. That I think is very important for wider adoption. And I think the other point that I wanted to mention is that Ceph is super, super good at recovering from failures that are uncorrelated, like a disk fails here, a machine fails there, that is designed to do that. What is kind of the scariest and kind of most problematic failures are things that are correlated, where everything fails the same way, and that everything, it could be the Ceph software itself. So if Ceph has bugs, releases that corrupt data, for example, that's a super scary idea for someone who's just getting started, or if someone who's using Ceph even. Having a confidence that Ceph releases are not corrupting data and that are reliable and don't introduce failures in the system is also very important. So all the testing that we heard earlier to test releases, et cetera, is super critical, I would say.
Yeah, I think that some way the Ceph documentation should improve would be like having different documentation, or like the beginner's documentation with kind of a target, and say, okay, if you are planning to achieve this, I don't know, you are maybe a small enterprise that wants to just spin up a virtual machine, this is what Ceph does well, this is how you should get started, and this is how you can go forward. It's not very clear now, and about that one, we were talking about hardware before. I don't even know is there an official guide that advises you what not to get or what to get in terms of hardware, and I don't think this is the case. Sometimes sometimes there are things that are not really, unless you know them, you can't expect it to find it anywhere in the documentation, and sometimes even in the community. We had the example before of, we are talking about the hardware RAID cards, and so meaning that you don't want RAID, but also you can use hardware RAID cards in JBOD mode. We always do it because the vendor is what they gave us, and we work in academia, so we just have to accept the lowest offer, and we never had any issues. So there are mixed signals. So what do you want to do? You want to use the cards, you don't want to use the cards. And this is for many documentations, for much documentation, this is the case, and you just have to kind of know. And this, I think, is problematic for someone that wants to start, and someone that also wants to say, okay, now I got my 4-node cluster running, everything works well. I have to move to a 50 nodes cluster. What am I going to do with it? What settings am I going to set? What do I have to be careful of? And this is kind of still something that you can't really find in the documentation.
Yeah, I think a lot of that's pretty good. The kind of taking outside of the hardware and the documentation, thinking about the workflows, right? It can be complicated to get a cluster up and running and doing what you need it to do. So to make Ceph a little bit easier to manage or more ubiquitous, we might want to start thinking about, is Ceph just a piece of foundational infrastructure, or is it a solution, right? And if it's a solution helping people solve a problem, then we need to start thinking about those workflows, right? Like, are you setting up your own internal private cloud? Do you need S3? These are all the things that come with it. These are the recommendations how it should work. Even kind of like you were talking about there, some of the stuff Ceph does really well like handling failures, being able to, seamlessly cycle in new hardware, take old hardware out. Like all of that's really, really great because you're disaggregating the physical storage from the logical data. But it's still complex to wrangle that at scale, and it's always a bit of a scary moment, when you add a couple new petabytes to a cluster at once, and you go, oh God, crush, please come back, peering, please don't take my cluster offline. So thinking about, from a solution standpoint, what are the people who are using Ceph trying to do? Generally speaking, most of the people that Bloomberg talks to and partners with, we're not using Ceph to use Ceph because it's fun and it's cool and it's interesting. We're using it because our businesses need it to make us money, right? So there is the cool, interesting factor. We're all engineers. This is super neat, and like we get to dig into the source code. We get to help work with the community. We get to fix bugs. But like on the other hand, we're running a business, and knowing how absolutely every single thing in Ceph works does not necessarily help me run my business. It's more of, okay, I need more capacity, or I need to take things off the data center floor, or I need to get more throughput or get better QoS here to have a better product or a better experience for all the application developers. So to me, that's kind of where I think you could attract more people if it was more focused on helping people do what, like a business function or what they're trying to do, as opposed to just being a super cool technology.
Yeah, I'll echo that. Definitely making Ceph more consumable, not just in deploying it, but how to use it. More workflow-based instead of just technology-based documentations or guides that would help. Like all the stuff that's I've heard talked about yesterday, today on the dashboards, on the Ceph ADMs and so forth, to kind of make the first deployment, kind of your first experience in Ceph. I think that helps in terms of attracting more organizations to at least try Ceph. But then when it comes to production deployment, especially scale production deployment, I think the robustness, I think, is one of the key. Reliability. So, with all these knobs to tune is one thing. You're getting 10% more, you're getting 5% less. It's just a variable. That's okay. But you tune these knobs wrong, you could lose data. You could take down your entire cluster. And kind of the checks, the prevention from kind of letting the user hang themselves, that I think Ceph can definitely use more in terms of kind of the safety check, right? In terms of, okay, if you tune this and tune that, but you also tune this, oh, that's a bad thing. And it should be more than just a documentation that's hidden somewhere. It should just be prevented from being allowed to do so.
Great. So I'm hearing a very common theme of we need more transparent hardware recommendations, or just recommendations in general about how to use this in a business and how to use it for my specific use case. I think that is really important, because absolutely Ceph can be complicated, and but one of the biggest things we're trying to do is make it more digestible. So always hearing feedback like this is really great, and yeah, we're in the process of making documentation edits right now. So I would like to see more of this in the documentation. I think that's a really common goal that we're all working toward. And just the fact that there's so much shared knowledge in the community about hardware recommendations, putting it all in one place would absolutely be helpful. So it's something I absolutely agree with. All right, so our last question. Based on your experience, what advice would you give to other decision makers who are considering Ceph for their storage needs?
So the very first advice, actually try it, run a POC and see how it works, if you like it or not. But I don't actually find myself that it's hard to spin up a very basic Ceph cluster. It's usually fairly simple work, so it doesn't take a lot of effort to, without any tuning or anything, like just for general use to see how it works. But apart from that, you always have to keep in mind that Ceph is not a black box solution that we just run and you don't need to maintain it. It actually will have, we require a lot of investment to integrate with your infrastructure, to have a team that keeps supporting it, upgrading it, adding new features, fixing bugs, and so on. And that needs to be accounted when deciding whether to go with it or not.
Yeah, so I would agree that that we should definitely start small And that's how we started, and that worked. See how things go. And when you invest small, if you make a mistake and you need to say, okay, something needs to be tuned on the hardware, it's not as expensive as a proposition. And if you went big and now you have to change out a whole slew of machines. The other is, generally, storage is different than compute because with compute, let's say you have some software that ran and it didn't work, okay, we just run it again and then maybe fix it along the way and run it again. With storage, you have your data there, so if it didn't work, you could lose data, which is a very, very different thing. So you have one of two choices generally. Either you pay somebody for support, that's the case with solutions, possible with Ceph also, lots of companies that are here that provide support, or you have to sign up for understanding a bit of Ceph, at least rudimentarily how it works, what happens inside, not all the details, but at least roughly, so that just for a comfort of sleeping well at night, that it's like at least if something happens, I understand what the message says, what is it complaining about, what could potentially be wrong, what would be an intelligent question to ask the community. So if you're self-supporting Ceph, you have to sign up for understanding a bit of the inside at the minimum, I would say.
Yeah, working in academia and research, usually we get a budget, and we don't have much budget or no budget for testing. So if you're planning to build a cluster, I would say that it's very important to communicate with the community if you are unsure if some hardware would or would not fit your needs. And because once, like the example that our colleagues was mentioning before of that center that was doing RAID OSTs with RAID 1 or RAID 5 or whatever. So there are these things that if you are working in enterprise and you're used to these settings, and maybe you give them for granted, so it's kind of a rookie mistake. You say, okay, maybe I'm going to add more redundancy to my system, but actually you're going to make things worse. And after you purchase the hardware, I mean, there is no probably way to go back. So what I say as an advice, just check with the community or with someone that already used Ceph what would be the best way of going forward, depending on your cluster size and your expectations.
Yeah, I guess I would echo a lot of that. Like really what it is Ceph is not you buy it and it's done. Ceph is a lifestyle choice, right? If you're going to do this, you're going to need to get involved with the community. You're going to need to be very intimate with the documentation. You're going to need to be very intimate with hardware, right? And Ceph is a great foundation if you can make that investment to understand how to run it at scale, right? If you're doing small scale stuff, testing and whatnot, yeah, it's manageable. But if you're running this at an enterprise level scale, you're probably not going to want to go it alone, right? Like you're going to need to, I mean, you said that, you're going to just need to be comfortable with the fact that it is an open source project. There are bugs in everything. There are bugs in vendor solutions, there's bugs in open source. And you know, that you're going to need to embrace the community for them to embrace you back to be able to actually make this a long-term sustainable play. So that's probably what I would say.
Yeah, I mean, it doesn't hurt to try it, but if you really want Ceph in a production environment, you have to be committed to it, right? There's no, I mean, overall TCO, Ceph is great. You know, once you understand it, you deploy it, you know, kind of adapt your lifestyle to it, like Matt said, and it's great. But it is an investment, whether you're investing by hiring your own people, building your own Ceph team, or you're going to third party for support or for software, et cetera. You know, you pay for it somewhere else, right? And so it's not free, but overall, I think you know, if you made the choice, it's a good choice.
Okay, thanks very much. All amazing insights. This comes to the end of our questions, and at the beginning we said we would invite for questions from the audience afterwards. Looking at the time, we have time for maybe one question. Is there any pressing question that someone just is dying to get out to, maybe one, or to hear from all of the panelists? Yes, okay. Please go ahead, Thomas.
So my question is this: I mean, I work for a small company now. We're using Ceph, but I came from a government institution, and this question of hardware specification. So my question is basically for those big government institutions. Certainly, when we had to come up with our spec when we built clusters, we couldn't. We had to be vendor agnostic. We had to be, we kind of really had to make sure that first of all that whoever responded to the specifications that we set out would actually build us something that would meet the requirements. So we came up with a small formula that basically worked out for, we're running OSDs, so we had, you've got to provide this amount of memory, you've got to provide this amount of bandwidth to the OSD, so that specified the kind of network that you had, and then the certain amount of CPU per OSD. So I'm just wondering, is this? I mean, so we have a formula that we use now. Well, that I certainly use now when we specify Ceph classes. I don't really think about the hardware. Obviously, we have some hardware targets in mind when we write up the specification, but because of this fact that we had to be more agnostic as to who we actually use as our vendor, because we wanted to generate some competition as well to make sure that we drive the price down. Do other government institutions do the same thing? I mean, yeah. So, I mean, is there not just like a magic formula that you can say, well, listen, if you really want to come out and, be vendor agnostic, build a Ceph cluster, this is what you could use?
I think just we have the formulas and we used them last time together to design the cluster. At the same time, what we found with the last procurement, for example, is that we overspec the cluster. So for the next one that comes, we actually want to get slower machines, slower networking, less NVMEs per OSD. And so this is something that is kind of difficult. Maybe if you are an enterprise, it is more easy to calculate these things. We are working with researchers that can say, okay, we want tomorrow 400 gigabyte per second, and then they want 4, and then they want 40 megabyte. And for the moment, we have a large ingest cluster, and we always ingest at the rate between 1 and 4 gigabyte per second, all day, all night. And the cluster is barely used for the size and what we have. So, for example, in the future procurement, we'll save almost 10% in hardware comparing to the cost per petabyte for the previous one, because from experience now, we know that we can go cheaper. So I don't know if this answers your question, but...
I think we'll wrap it there. I wish I could hear from everybody, but thank you so much, panelists, for being here and for volunteering your time. I've loved hearing from all of you, and thank you so much for coming.